So these are our notes on titration. Titration is a pretty easy topic. It's actually our last math formula on the back of the reference table. So it's the last math formula for the year. So hopefully we're all excited about that. There are some vocab words, but I'll get into what titration is. Basically, the last video talked about neutralization and hydrolysis. Well, a titration is a measured neutralization. So it's not simply you mix an acid and a base and you get a salt plus water. We need to know exactly how much acid it took to neutralize a certain amount of base, or reverse is also true, so that we get and we also need to know that when we're done, that we're exactly neutralized. In other words, the pH is 7. So there's a lot that goes on in a titration. First, you have to use a known concentration. So that is usually called a standard solution. Should be a D there. Standard solution. And basically, it's a solution that you make it. So you know exactly how concentrated it is. In other words, you know the molarity of that solution. You then use an indicator that will change color around pH 7. Now, obviously, there are no indicators that go exactly at pH 7, but we get one that goes as close as we can. If the color change, whether it be the left color, the middle color, or the color on the far right, as long as there is a change that is within one pH number of pH 7, that's pretty much good enough for us. And pH 7 is called the end point or the equivalence point because it is the point at which we know all of the acid has been neutralized by base or reverse. So it's also, so that's where equivalence point comes from, and it's the end of our titration, so it's also the end point. So they both mean the same thing. Now, on the reference table, they give you this formula, MAVA equals MBVB. MA is the molarity of the acid, VA volume of the acid, and then the B's are for base. Now, I'm going to add this in, the number of H's and the number of OH's, because this will affect the formula quite a bit. So, for example, if you were using HCl, this is what's called a monoprotic acid. It gives off one H. So if you use this H, it doesn't really matter. I mean, this acid, it doesn't matter. But if you use H2SO4 or H3PO4, they give off 2 and 3 H's respectively. So therefore, they're acting as an acid twice for this one and 3 times for this one. So although we have a specific molarity, we would have to double it or triple it in the case of these 2 acids, because it's like having 2 acids in one. And it's for the base as well. You could have a monobasic one, in which case it would just be give off 1 OH. So if you forgot this part, it would be fine. But if we used CaOH2 or AlOH3, they act as a base 2 and 3 times. And so we would have to worry about doubling or tripling the molarity, because it's like having 3 times the amount of acid that you actually have. So let's do some practice problems, and then I'll show you how they work. So the first practice problem says how many milliliters of 0.45 molar. So if you notice, this is the molarity of this acid, and that acid is specifically monoprotic. So look at what I found out so far. So here's my formula. So I know it only gives off 1 H+, so that's good. I know my molarity is 0.45. You can put the unit in there. And they want to know how many milliliters. So there's my volume. One thing to note with the volume, it does not matter which volume unit you use, as long as VA and VB are the same volume unit, meaning they could be milliliters, centiliters, liters. It doesn't make a difference. As long as they are the same unit, that's all that matters. And then they want to know how much of this will neutralize 25 milliliters of 1 molar KOH. So that gives off 1 OH. It is 1 molar. And then its volume is 25 milliliters. So there's my setup. Multiply these together, multiply those together, divide out to get X, and you end up getting should be a lowercase l. But there's your answer, 55.6. So try that one on your own. Make sure you're doing the math right. I think the actual answer is 55.5 bar, but I rounded, so whatever. Number 2, what is the molarity of H3 of a H3PO4 solution if 15 milliliters is completely neutralized by this many milliliters of this molar, this chemical? So let's see what they gave me. They told me the formula, and this formula can give off 3 H's. So now I have to put a 3 there. They told me I have 15 milliliters of it. They want the molarity. They gave me NaOH, which has 1 OH, so there's a 1. They told me it's 0.15 molar and 38.5 milliliters. Solve for this one, and you end up getting that answer. Okay, so double check that one. Make sure I'm doing it right. Make sure you're doing it right. And then for number 3. Number 3, think of it as an example or a demonstration problem. It's really here to show you just how complicated or how involved these can get. I doubt you'll ever see anything like this on a Regents or a final for that matter, but they want to know how many grams of H2SO4 are needed to make a 30 ml solution that will completely neutralize 50 mLs of this strength of that compound. So we can't solve for grams directly. The only thing we can solve for, given the information, is we can figure out how many, what's the molarity of the H2SO4, and obviously this is going to be a multi-step problem, so we'll call this step 1. So let's figure out what we know. We know we have 30 milliliters. They want to know, we know that it's H2SO4, so that's a 2. We don't know the molarity. We know that the base has 1 OH. We know that its strength is 1.15 molar. And we know that its volume is 50 mLs. So we solve for X here, and we end up getting 0.98 or 958. So there's my first answer. Obviously not my real answer because they want grams. I still don't have grams. Next step. We know the molarity formula is moles over liters. My molarity is 0.958. I want to know how many moles it would be. Still not the answer though, but it's a step closer. And the liters, well, they told me right here that I have 30 milliliters of the original solution. So convert that using King Henry. You get 0.30. Cross multiply, and you end up with, I'm not going to round on this, but you can if you wanted to. So I get this many moles. Final step would be mole formula. I have that many moles. I want grams. My GFM is 98. Solve for that, and I get 2.8 grams of and that's my final answer. So as you can see, these problems tie in with, they can obviously tie into the molarity formula and to the mole formula, meaning that you could in theory be asked to use all 3 of these together in a chemistry lab or in any type of chemistry job. We would use these together all the time. This would be pretty standard. There will be a CASA learning on this, and that is it.